questions to hear? So how do we find displacement? In unison would be really cool right now.
Average velocity times time.
Yeah, just think back, if you drive on average 50 miles per hour for 3 hours, how far did you go? Multiply rate times time. So average velocity. So my displacement is just average velocity times time, so 5 meters per second, times 10 seconds. Take a dramatic pause here for people to catch up and to think about the next one before I officially ask. How do you find change? Mathematically speaking, not looking at the calculations. Ashley?
Final velocity minus initial velocity.
Okay, specifically for this one, yes. In general, final minus initial. But, so we have, let's see. So my change in velocity is the final velocity minus the initial velocity. So negative 20 minus 30, which is yes. Units? Meters per second. All right, we're cruising now. Negative 50 meters per second. So acceleration. How do we find acceleration? Ashlyn? Do it unless someone else is about to interrupt her. Okay, Ashlyn?
Change in velocity divided by change in time.
Say it again without the question mark.
Change in velocity divided by change in time.
There we go. All right, so acceleration. Change in the velocity divided by the change in time. So that is negative 50 meters per second, because we just calculated that, divided by my time of 10 seconds. And we end up with
Negative. Meters per second squared.
it is just coincidence, because the numbers I picked, that I've got a 5, negative 5, and a 50, negative 50. That is that. I wish that were not happening right now, but I picked nice numbers so they can't, so we weren't having to deal with fractions at the moment. All right, questions up to here? All right. At what time did the object stop? More than one way of solving this one. There's a sort of a brute force method, and which isn't too bad because the problem only takes place over 10 seconds. Or there's a more math way of doing it. Let's do them both. So the more brute force method is that we'll just set up a little chart here. I got time in seconds. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's when the problem stops. First off, how do we know it's going to stop?
acceleration is negative?
I could have negative acceleration and it not stop if I slightly
Because
different
you
numbers.
dropped it, it's gonna eventually hit the ground, right?
This is not
Oh, this
necessarily
is
up and
the other
down.
one, sorry.
Because of the displacement?
The displacement's positive. Why is that telling us?
Because it's saying the distance. It's saying the distance? I'm guessing.
There's another important clue here that tells us that it turns around. I know it stops because it turns around, sorry, I was explaining some of that. How do we know it's gonna turn around?
Because of the negative.
velocity changes, and velocity is, the direction and its speed, and it says it changes from 30 miles a second to 10, or to negative 20 miles,
Meters.
meters per second.
Yes, and that's exactly it. Because the velocity switches signs, we know the object's gonna switch directions. And if it's switching directions, it's a one-dimensional problem. If it switches directions, it has to stop in between. All right, so I have my velocity here in meters per second, and it starts out at 30. How much is my velocity gonna change each second?
Five,
Why?
because the average velocity is 5.
Oh, no. And this is the trouble with having
The acceleration. Or the change in velocity.
This is related, this is -5 meters per second each second, which we shorten to just meters per second squared, but it's, the velocity will change -5 meters per second every second. So after 1 second,
25, 20,
keep going.
15, 10, 5, 0,
Yeah, let's just keep going.
negative 5, negative 10, negative 15, negative 20.
All right, one of the reasons why I wanted to keep going is that after 10 seconds, if we did it correctly, we should end up with that -20 right there. So this is just confirmation that we've done something correctly. All right, at what point did it stop?
6 seconds.
Yeah. That's what we're looking for. We're looking for that 0 meters per second right there. What time did it stop? At 6 seconds. And now, the distance. I know it turns around. It's traveling in the positive direction, will stop, go in the other direction. It will end up 50 meters from where I started. Positive 50 meters from where I started. Doing the fancy drawing, it starts someplace. It's gonna be moving in the positive direction, I'll just make that positive. It's gonna stop, turn around, come back, it will eventually end 50 meters on the positive side of where I started. And I know that because that's what that's telling me. So if I want to find the distance that I traveled, what do I need to find? Is this just this carryover sadness because we didn't have lab on Friday? Gabby, you have the answer and just. How is the distance different from the displacement?
You have to find
No, it's not related to the order.
Direction doesn't matter.
Yeah, displacement is where you are at from where you started, not how you got there.
Okay, so, but distance,
Distance could be longer? Because
It won't be
dep-
smaller.
It won't be small, because it depends how you got to where you're at.
Okay, so we need to figure out how far did we go this way and how far we went that way.
Yeah.
So if I'm thinking about how far did we go this way, well, I know this happens, at what time does this happen?
6 seconds.
Yeah, that's 6 seconds right there. What's the velocity at this point?
Yeah.
And I start out going 30 meters per second. So in that first 6 seconds, what's my average velocity?
180.
5 meters per
15.
second.
That answers a different question, I think. My average velocity, I start at 30 meters per second, I get to 0. My average velocity,
15.
15 meters per second.
Okay.
I go 15 meters per second for an average of 6 seconds. Sorry, I go an average of 15 meters per second for 6 seconds. How far did I travel?
90 meters.
Yeah, just multiply again. So that's 90 meters from there to when I turn around.
What did you multiply?
For that first 6 seconds, the average velocity times time.
Oh, okay.
Where did you get 15?
I know I start at 30 meters per second and I turn around at going 0. So it's the average of those two numbers.
Okay.
If I go 90 meters in the positive direction before I turn around, and I end up 50 meters in the positive direction from where I started, how far did I backtrack?
40 meters.
I heard it said very softly. If I go out 50 meters and I know I end up, go out 90 meters and end up 50 meters from where I started, I have to go back 40 meters to get there. So the total distance I traveled, well, I took 90 meters out, 40 meters back.
Would be 130.
Yep. 130. And how do I find the average speed?
How did you get 138?
Do you see where the 90 came from and the 40? Just added them. 90 meters out, 40 meters back, the distance is just the sum. Alright, so, average speed? How do you find average speed?
Displacement over change in time.
Say it again?
Displacement over change in time.
That would be average velocity. Look for average speed now. Pardon?
I thought that was average speed.
When you said displacement, you made it a vector.
You add all of that divided by the number.
Oh, you're, no. There is a way of doing it that path, but it's more complicated than just adding them up. If you added them up as is right there and divided by 11, since I have 11 numbers there, you'd end up with 5 as your average. Doing it that way. If you just made them all positive because those are speeds, then it gets more complicated to do it that way. There's a much simpler way of finding average speed. You were so close.
The distance over time.
Yeah, distance over time. That's one of the reasons why I had to find distance before finding average speed. So the average speed would be the distance over time. Notice I'm not putting a vector symbol over that. It's the distance over time. 130 meters over 10 seconds. 13 meters per second. That was a fun little problem. Yes, Chase.
For the, what time did the object stop? You said where you can do a math break, can you show us the time?
Ah. Thank you, I forgot. All right, so I know that acceleration is the change in velocity over time. I've already found my acceleration by then. My acceleration was -5 meters per second. So I got -5 is equal to my change in velocity. Well, if I'm going from 30 down to 0, it'd be 0 minus 30 divided by time. So you'd end up with -5 is equal to -30 divided by time. Solve for time. Multiply the diagonal you do, divide by what's left over, so I get -30 over -5, which is 6. I know, you're looking at this and going, wow, that's just so incredible. I'm speechless. But for those who can recover more quickly, are there any questions? All right, so let's change it. Straight line, I'm going to keep that the same. Initial velocity, sure, I'll keep that the same. And then, let's get rid of that last sentence. Anyone still need the numbers up before I erase them? Over the next, we'll keep time the same, 10 seconds. The object accelerates at -6 meters per second squared. I'll have one other question. What is the final velocity? I'm gonna leave these here, just, even though all of you should know what the answer to this question is at this point. But I've done this on other tests where I start out with what's the acceleration, and people write it down, and then I ask a whole series of questions, and at the end, I ask what's the acceleration, and have people come up with a different answer. Because at that point, their brain is not, it's in a different place. All right, so final velocity. Brute force. Time in seconds. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Velocity, meters per second. So I start out at 30. Well, how much does the velocity change every second?
-6.
Yeah. That's what this is telling us. So that would be 24, 18. Do math here, all right, 6, 0, -6. Here. -12, -18, -24, -30. What is the average velocity? So the answer to the first one, negative 30. The average again?
0.
How'd you get that?
It's in the middle.
30 and
Oh, yeah, that works too, if there is a middle. But my final velocity is negative 30 meters per second. My average velocity, you average the first and last, because the acceleration is constant. And so you end up with 0 meters per second. So what's your displacement?
also 0.
0, right?
Yeah, on average, you went 0 meters per second for 10 seconds. Now, let's say that you are not in that mind frame, you're more in a math equation mind frame at the moment. We could solve that a different way. That equation that I had written up on the board, that displacement is equal to the initial velocity times time plus 1/2 AT squared. My initial velocity is 30 meters per second times 10 seconds plus 1/2 times negative 6 meters per second squared times 10 seconds squared. Or math-wise, 30 times 10 plus 1/2 negative 6 times 10 squared. Then you get 300 minus 300, which the math people tell me is 0. What? No questions up to there. What is the change in velocity?